Okay, let me help you determine which your lift, installing your lift. Let me grab my calculator, opening it. All right, so let's just work on each lift. They appear to rate each arm. So if you have a 10,000 pound lift and it's 4 arms, they rate it at 2,500 pounds per arm. So what we care about, I'm going to use 2 videos here in this thumbnail. So what we care about then is this going to, for a 10,000 pound lift, this will take 5,000 pounds. The base, you're going to divide the base up, and that's what you're going to get per square inch that you need to deal with. I think it's critical that you do not use shims and the capacity that I think this person used it, and I've seen the manufacturer recommend these shims. The shims create point loading that's well in excess of the base plate distribution. It's distributing through the shims at that point, and you're down to, I don't know, 4 inches at that point. So it's critical that you do not use the shims. Now let's go for reference. Let's look at this guy's video in the background, and let's look at what you don't do. Okay, so he said this almost killed him, and he took the bolts off. He rented equipment. He then, let me pause in the background, the volume. He rented equipment. He's showing his bolts that he's taking out. He's then dowing into the side. Okay, so his concrete's going to go in here. There's his wall in the back. That's his camera legs there. And this is what it looks like when well, I guess that's the diagram, but this is true life. His wedge slid up. His wedge fractured off the bottom, and there's his wedge grip and his head rotation of his columns coming towards him, and he thinks it almost killed him. I do not think he popped this that easily, so I don't know how that presents as that. Maybe smashed it with a hammer. There's his story. You can go over there and find it. He mixes his own concrete up. He then places it inside this. This is where he's going to place his column. If you see here his ties, this rebar, he doweled it, and then he put this hashtag place dowels in there with these what are those zip ties around here, and they're just loose, and this is ridiculous. They're ridiculous. This is yeah, and it's super. This is ridiculous. All right. So that's one ridiculous one. Let's get rid of that, and now let's go to the guy here. He finds out that he's got 3.5-inch slab, so he decides to take it all up. Just mute it. And him and his buddy, they make this huge slab. Okay, this is a waste. It's a waste. Your columns are all you care about. These columns, this is the distribution of the load. This is pretty much all a waste. This will help you with some pull-out. I want you to think of the column as a fulcrum that once you load it, it creates a torque that wants to rotate it over. Here's the counter force of that, the base in the front, as this wants to fall inwards toward the car. And so you have a lot of pull out here, and not as much pull out here, but more on the back screws. So now I want you to look at this little diagram I did. So this will be your footer. It's going to be a quick down and dirty simple version. I want you, instead of using since you're going to dig down, I want you to check your soil. You're going to dig down. You're going to make sure your soil is able to take the distributed load that you're going to apply to it. If you've got soft soil and you test it and you find out that it can't take 40 pounds per square inch, then you know that, well, you need to reinforce your soil more. You need to get down to a tighter torque of the soil, a tighter distribution of the soil. And that can be done in different ways, such as driving pipes down. So say you have this and you're going to load, you don't want this to load to the 5,000 pounds. Start driving your foundation downwards. So you might consider driving some steel galvanized pipes into the ground to make like a pier system. Okay, I'm going to help you work with your shooty soil. And you might do this, drive it down into the ground, and you're going to work with skin surface tension, and you might go all this is hollow, but you might decide to do something like that. All right, so you're going to drive some pier piles, galvanized pipe down, 1/4-inch steel galvanized. All right, nice and deep. And then you're going to put your concrete on top of that to help you with this distribution. You don't want your concrete to fracture either on the top of these piers. So you're gonna dress it up pretty nice. You know, it's gonna not be a joke. You're gonna make it so this pier system distributes pretty well. Now, if you don't need that and you just happen to have some good tight soil, that's great. And you'll just pretty much gonna go with something like this. This is where you're going to distribute your load. I like to see this for at least 12 inches. I'd like to see you then put some rebar across here, on the bottom part of it. I like to see you put another, this shape of rebar here, down it. And I want you to put another piece of rebar across the top there. And then these two blue ones. This, instead of using those anchors, this is going to be your galvanized thread awl. You're going to place these via a template how this will work in the ground. This is what you're going to put your post on. You can cut these, bevel cut them, don't try to cut them square. They take a galvanized head also. You're going to galvanize these. These are going to be your anchors. This is going to be your pullout. Now, why the shape of this? Well, I want you to imagine if I just give you this shape of 8 inches as you load your column on top of it. Let's just say it's like this. This column here. And here's your lift, all right, your car loading. This creates a torque. This wants to fall down. This creates this rotation. I'm going to give you a rotation like this. From the bottom there, on this side, your rotation is this direction. And it's going to make this want to rock. So your footer here is going to want to rotate downwards. And this is why I want you to do this. This is going to allow it to not rotate. It's going to create a lot. You're going to have a lot more surface tension over here and a lot over here also. It's not going to allow it to rotate. The reinforcement that I configured for you is going to make this react as one. So instead of just this, you're going to have now 2 legs on the bottom. Move that out of the way. You're going to have these 2 legs that are going to act as one. It's going to make this whole unit act as one. And it's not going to be able to rotate. You see the rotation will try to take place? It's too big. It's going to try to rotate. It's going to have to push down this, pull up on this one. It's going to act as one because of the reinforcement I gave you. You don't have to worry about this just reacting as pulling out just on your bolts just through your fatigue and failure there, because you're going to use this galvanized rod that's going to double as a reinforcement that make this act as one. You don't have to fill this in there. That's just mass if you want to. I would probably prefer you would not do that, because then I'll have to add that to the weight of the vehicle of your how much it would take for the foundation. For your footer would then have to be increased. Its load capacity would have to be added. Concrete weighs 150 pounds. You're going to add an additional 300 pounds, 400 pounds, 500 pounds on that same area. You have to just add it up into your total surface area. This is not unlimited that you get to make this bigger and then do the distribution that way. The concrete will not behave in that manner. I want you to use so if this is a I'm going to give you a base plate now. The base plate is 18 by 18. 18 by 18. I just want you to double the numbers, okay? Just double it. So it'll be 36, and I want you to do it like that. And it's 36 by 36. Just double it. And the reinforcement, yes, please do your reinforcement of that capacity. But there's no reason for you to pour this entire pad over. Isolate it, yeah, that works. If you've got a nice pad already, this 8 inches, give it a shot. I would do a rebar pullout test, anchor pullout test on it though, to see how it performs with your to see if you get the capacity. So you would do that somewhere where it's sacrificial. That would be over here where you can plug it and fix it. You pull it out to failure. You put the anchor in, and then you pull on it to. And it's not a rebar pull out; it's an anchor test, and you pull out of it and see what its failure would be, and that would be the back side more so. The front side is going to be the compressor side. Your bolt side, the tension side to hold it down, will be down in the back side. That would be times whatever two bolts. Do not think you can just drill more holes and add more bolts to get more capacity. The closer you put these together, there's a cone effect that will overlap, and you don't want the cone to overlap. You'll just create a stress zone. Say if I move that one over there and I just happen to bring it closer because you know what, more is better. You're overlapping, you're actually making a weaker section. You want these to be outside their influence, to make their own individual cones with some margin between them. And that's why they have the bolt patterns at the distance that you see. So wrapping this up, 36 by 36, think of the load testing of that soil. If you can't get there, think of adding the steel, the galvanized to drive it down. And then I want you to tie it. This will be load supporting, supporting there. And in this case, if you do that, then yeah, you'll probably just run the concrete straight down. 36, double it, just double it. That's my best margin for you. You don't have to double it. You can just treat it as a long extended post in the ground. I would prefer that you double it for my advice to you. Now I put these little links here because I'd like you to tie these top one and the bottom one together with little bent links like that, little shear links, so they act as one. So right there, link, link, link. And since you're only doing two of them, place them every one at the end, one near the each end, and then go 4 inches apart. I would really like that. Again, your rebar, you see 4 inches. Yeah, I'm okay with 4 inches. I couldn't make it wider, but I have a reason for it, for the extra beam capacity that you're creating here. So basically, I'm making a beam for you. I've got redundancy for you, because my recommendation is going to be the best for you, and you're going to use the thread all. You don't have to worry about using epoxies. You're going to get your bond strength through all the concrete binding on the galvanized thread all that you'll run up. Okay, that's the end of this video. Hopefully this will help you understand it better. Feel free to ask questions. Maybe you just go over this again. I think I covered it all, the rotation, etc. This even covers that, that soil that might be a little funky down there. Isolate it with expansion joint around it. You don't have to tie it into existing concrete with dowels. That's not necessary. In fact, it would not be recommended. You would want to observe to see if this is actually sinking, and that way you know, oh, I didn't do this good enough here, and at least then you'll be able to monitor it. The dowel would be in the side of your slab. It could be stressing there, and you might not see it, and that's just a issue that I don't want you to deal with, especially if you get water down there and the dowel start expanding. It can start fracturing your concrete here and changing this behavior of this, and I'd rather you just make it behave as a single column times 2. All right, hopefully this is helpful to you on how to, my recommendation on your proper, to take care of the deadliness, if you will, of these things rotating in. The other thing you could do if you had a high enough lift to stop these two lifts from rotating and hitting each other. So there's lift 1. That didn't work. Here's lift 1, right? And let's get rid of, here's lift 2 over here. All right, you put a spreader bar across the top. Now that will stop that reaction. It will take a lot of stress off the bottom. So you're going to put a stiffener across the top here. Yeah, you got to worry about your car at that point. But now this will stop these from rotating in. It will keep the stress off the back bolt. That really helps. That's why they get that slight bit there. And you can make it sacrificial if you like. You can make it a little bit smaller that it will buckle. And then you know, oh, our columns are really bending inwards at this point. So that's a thought for you. Um, Especially this would be good if you do have a smaller, these uprights are kind of flimsy. The stiffener would really help. End of video. Hope this is helpful. Take care. Bye.